Hello all. I welcome you on behalf of Edureka for mastering Git and GitHub roles. In the last module, you learned about how to install, set up, and configure Git on different OS. You also saw the different configurations possible. You also created an account on GitHub and worked on the remote repository. In this module, which is remote repository, you will learn the Git lifecycle, work with basic Git commands, and understand local and remote repositories. You will also work with remote repository and perform the Git operations on them. These are the objectives. As I stated, we will be working with the remote repositories, configuring them on the GitHub, understanding some Git buzzwords and the remote commands. We will also work with the fork and pull request in GitHub and understand the upstream and downstream. So what is a repository? The purpose of Git is to manage a project or a set of files as they change over time. So Git stores this information in a data structure which is called a repository, which is simply a place where history of your work is stored. It often lives in a .git subdirectory of your working copy, which is a copy of most recent state of the files you're working on. So repository contains history of the entire project. This copy is retained throughout the lifetime of the project. So if I go back to the project, so this is the Hello World project which we cloned from GitHub in the last module, and if I look at the project structure, then this is the .git zip directory we are talking about. So the clone command repository to a local computer. During this clone operation, the file, data, and other metadata is copied from one repository to the another. However, the configuration settings are not propagated from one repository to the another. Configuration settings may be the user. If you remember, in the last module we did configured the username and the user email ID. So all these configuration settings are not propagated. However, the metadata of the project is copied. It means the history. To check, for example, the logs, we can do git log, and this is the metadata I'm talking about. So I have the complete history of the project, what happened when. Now within a repository, Git maintains two primary data structures, the object store and the index. All of this repository data is stored at the root of your working directory in a hidden subdirectory named .git, which is same that we saw in our project, which is this directory we're talking about, .git. Let's discuss what is object store. So at the heart of Git repository implementation is the object store. It contains your original data files and all the log messages, author information, dates, and other information required to rebuild any version or branch of the project. Now there are four Git places only four types of object in the object store. Git places four types of objects in the object store. These are the blobs, trees, tags, and commits. These four atomic objects form the foundation of Git's higher level data structure. So blob is, let's discuss the blob first. Each version of the file is represented as a blob. Blob, a contradiction of binary large object, is a term that is commonly used in computing to refer to some variable or file that can contain any data or whose internal structure is ignored by the program. So blob is treated as being opaque. It holds a file's data but does not contain any metadata about the file or even its name. So tree object represents one level of directory information. It records the blob identifier, path names, and a bit of metadata for all the files in one directory. It can also recursively reference another subtree objects and thus build a complete hierarchy of files and subdirectories. Then comes the tag. So the tag object assigns an arbitrary yet presumably human readable name to a specific object, usually a commit. Although the hash value refers to an exact and well-defined commit, a more familiar tag name like version 1.0 alpha might make more sense. So tag type contains tag name, author, date, and message. Then at last comes the commit. So commit object holds metadata for each change introduced into the repository, including the author, committer, commit date, and the log message. Each commit points to a tree object that captures in one complete snapshot the state of the repository at the time the commit was performed. The initial commit or root commit has no parent. So over the time, all information in the object store which contains these four types of objects, will change and will grow. So tracking and modeling your project edits, addition and deletion will introduce more information into the project. Now, to use disk space and network bandwidth efficiently, Git compresses and stores the objects in pack files, which are also placed in the object store. The second type of data structure we have is index. So index is a temporary and dynamic binary file that describes the directory structure of the entire repository. Second, more specifically, the index captures the version of the project's overall structure at some moment or in time. And the project's state could be represented by a commit and a tree from any point in the project's history, or it could be a future state towards which you are actively developing. So index is used to keep track of file changes over the working directory, staging areas, and or repository. So what are the contents in the index? Although it is often useful to think of staging area as some real area or directory where Git store changes like it does in .git objects, this is not entirely true. So Git does not have a dedicated staging area where it puts some object representing file changes, which we call as blobs. Instead, Git has a file called the index that is used to keep track of the file changes over the three areas: the working directory, the staging areas, and the repository. And when you add changes to your staging area, Git updates the information in the index about those changes and creates new blob objects, but puts them in the same .git/objects directory with all the other blobs that belong to previous commit. So this is where it will, if I go to .git, I have my objects directory. This is what I'm talking about. So let's say we are on a branch master, or we are on a head within the branch master, and there is also a branch name feature. So my head is now pointing to the feature. If we now do a git checkout, if we do execute the command git checkout feature, three things are going to happen. First, Git will move the head from pointer to the point to the feature reference, which is my branch, because by default the branch is master. Next, Git will take the content of the commit that feature is pointing to and add it to the index. And this is how the index will look like, and it contains the following information: the m time, which is the time of the last update, file name of the file, then the file version in the working directory, file version in the staging, and the file version in the repository. And these all are similar to what we are seeing here. So these are the objects. So let's see that how does index works. In step 1, we execute git command to stage changes in the index. For example, I'll do git add or something. So changes usually add, delete, or edit some file or set of files. So these files can be tracked or they can be modified state. In step 3, index tracks and retains those changes, keeping them safe until we commit them. So all those what is there in the staging area will remain safe. In step 4, you can replace or remove changes in the index. So I can unstage those comments, or I can reset my head. So this is what we're talking about. If we have a remote repository that is living somewhere in the cloud, and we have two collaborators which are named developer A and developer B. So developer A has the working copy, the staging area, and the local repository, wherein he is updating or doing various things. For example, first when it clones the repository, it comes as the working copy. Then it can add or make changes, bring new things to the or new files to the staging areas and commit them. Same is the case with the developer B, wherein he is executing the following commands: clone, fetch, push, pull. We'll be discussing all these commands in detail in the coming slides. But for now, this is how the local and remote repository look like. So developer A and developer B have their local repository, while the remote repository is living somewhere in the cloud. Every time they make a change, they push their changes to the remote repository so that developer A or B can update or can fetch the contents that the other developer has committed. So as we discussed before as well, local repository exists on your local system. It will also contain the metadata, which that is, it will contain all the files which is like required and their commit history. So commit history generally comes under the or is does come under the metadata. Now, once we have the metadata, then we can have the history review, diffs, and committing when we are offline. Having full repository history is one of the key USP of Git, which is part of distributed version control system. This is something that we discussed in the module 1. Now, if we talk about the remote repository, then we have a centralized server which acts as a remote repository. For example, GitHub is a remote repository because we have a centralized servers, and I can also add more collaborators in it. It does not reside on a local system. However, we can clone it or fork it. We saw the cloning in the module 2, wherein we created a new Git repository and we cloned it onto a local system. It is shared by different teams and worked upon at the same times. By different teams, we mean that we can add the collaborators in the GitHub. They are part of collaborative projects. By collaborative, we mean that more than one people who can modify or make changes in the project are working on it. So these repositories are the version of your projects that are hosted on the internet or network. Not just hosted, but they are also making us collaborate more effectively with different developers in place. We can work on multiple branches, which is another USP for the Git, in parallel. So for example, I can have a branch name developer, then I can have a branch name feature, then I can have a branch name bug fix, and I can work in parallel and then can go ahead and merge them when required. So let's use the git clone command. So generally, how do we create a local repository from a remote repository? For example, if I have a project in GitHub, so let's open our GitHub. So this is my GitHub account and these are my repositories. So I have a hello world repository. To clone a repository, I have to execute the git clone command and enter the repository URL. So repository URL is available here. I click on the clone or download button and I have my repository URL. I can click on this button to copy it. Once it is copied, then I can go ahead. So let me clone a repository again. I will create a directory module 3 and I'm do git clone and then paste the repository URL. So what it will do is it will download the repository, all the files in the repository along with the metadata onto my local system. So now I have my hello world project. If I go into hello world, I will have my all the git contents. So I have my git and the objects in it. So we did nothing, we just executed this command git clone in the repository URL. Repository URL is the remote URL that we can have from the GitHub page or from any remote repository where it is hosted. So there are different buzzwords which are there in the Git we are going to discuss. For example, we have master, which is the name of the default branch. Then we have def feature branch, which is the new branches that you can create. We have a head, which is reference to the last commit. We have a clone, which is used to check out repository into a new directory. Then we have origin, which is the name of the remote by default. However, we can also change it. Then we have push command, which is used to upload local repository contents to the remote repository. We have fetch, which does not merge. So the difference between push and fetch plus merging the repository is generally, so push is doing nothing, but it is fetching the contents to my local repository and then it merges. So if I fetch, then the merge won't happen explicitly automatically. However, I'll have to do the merge explicitly. And collaborator is someone who is on the co-development team of the project and has commit access to the main repository. So let's discuss all of these in detail. So master, as I said, is the default branch that Git creates when the repository is initialized. So it will have a default name master. It is the first point of contact for any developer. However, I can create new branches with the git branch command. For example, I can have a new branch name feature, which will be created from the default branch or from any other branch if I'm on it. But as I said, the default branch, if I initialize a project, the default branch will always be git. For example, let's see and initialize the project. So I'll make directory my project and I'm going to initialize this project. And if I do now git init, then this is initialized and I have to look at the branches. Then I'll do git branch. We are on branch master. I don't know why it should have listed the branches. This is the git branch command will do. If I type it automatically, then these are all the options that I can do. I can delete a branch, I can move a branch, I can copy it, or I can look at the remotes, I can list the commands, all these things. So I don't know why we are not getting this, but generally it will reflect the branches. If I go, for example, to hello world and I type the command grid branch, then I'll have master, like it is coming here. We have only one branch on the hello world, which is master. This is the default branch we are getting. Any new commit on the master branch moves master to the new commit. For example, the master is at snapshot C, then we made some changes, we got to snapshot B, then we made some changes, and then we moved to snapshot. The next comes the branch feature. So feature branch is created when any new feature comes into development. There is no such thing as feature branch. Rather, what it means is that we can create a new branch which is named as feature. So branches is the main strong points of Git, which allows multiple developers to work on particular feature in parallel. So I can have a master branch wherein the main work is going, and I can have another branch feature wherein I need any urgent feature, or I can have another branch named as bug fix where I'm doing the bug fixes in parallel, and once that is done I merge them with the master later on. So this protects the not just code breakage, for example, but it also helps me to work into parallel. For example, it is also general practice to have three branches. For example, I'll have my dev branch where I'm doing the development, then I'll have a QA branch. So once my project is from dev is done, it will move to QA, and then once it is in QA, then I'll move it to the production branch, or the branch which is, or the sandbox branch, right? Now, how do we create a branch? For example, I'll go to my project. So how do we create a branch? I just do git branch feature. So if I do the git branch now, I have two branches now, master and feature. To use the feature, I'll have to do git checkout feature. And now if I do the branch, so I'm on the feature branch now. I can also create the branch directly. For example, I can do -b, let's call it bug fix. So this is what I did. I created a new branch feature and then I checked it out, or I switched to the branch. So this is how I switch between the branch. I just do git checkout master and my branch will switch automatically. Then comes the head, which is the pointer to the latest commit for the working branch. There is always one head per repository. When we switch the branch, the head will point to the latest commit of the selected branch. For example, if I'm on branch A and I have switched it, then the latest commit will be, head will point to the latest commit, right? And after each commit, the head, if I commit and if I make any new commit, then my head will move accordingly. For example, this is the here that I have different commits, and in branch A, I'm on branch A right now, for example, and my head is pointing to the latest commit, which is C3P0O0. There is one small exception to this, which is called as the detached head. So detached head is the situation you end up in whenever you check out a commit instead of a branch. So in this case, you have to imagine this as a temporary branch without a name. So instead of having a named branch reference, we only have head. It will still allow you to make commits, which will update the head. So the above short definition is still true if you think of a detached head as a temporary branch without a name. Then comes the clone command. So this is the command to copy the existing repository from a remote one, or downloading the remote repository to a local one. This is similar to checkout in SVN, with only difference that clone will get the complete repository, whereas checkout will only fetch the working copy. By complete repository, we mean all the files and the along with the metadata. So this replicates the repository on local machine for the first time. Then comes the origin. So origin is by default the remote repository name. If I go here and if I do remote, then this is the origin, because this is what it is called so far. So origin is a alias, or we can say the local name on your system for a particular remote repository. We can also change this, but by default it will come as origin. It is useful to point out the default repository when running git commands instead of the entire repository URL. So by entire repository URL, I mean this. This is the entire repository URL, and we there the alias is created automatically. We discussed the how to create Git alias yesterday. So the Git alias allows us to create some short command so that we have to type fewer keywords, or I should not the keywords, but the fewer keystrokes, I should say. For example, here the end origin is pointing to this get URL, github.com/remote, and in our case, it is pointing to this hello world.get. This is what is happening. We have this repository, we are adding remote repository as the origin, and the remote master, which is the origin, is pointing to the latest commit. Next comes the command push. So we have been using this command since the day one. So push is used to upload the changes from my local. So changes, only those changes which are not in the staging area, but the changes which have been committed. So it will push the changes which have been committed in the repository from local to the remote. For example, if I have modified the file, or if I have added a new file, the next thing I'll do is I'll move it to the staging area using git add. Now once that is done, I will commit it. Now after this, once it is committed, this commit will only reside in the local repository. To make it to the remote, I'll have to push those changes. So the command git push will come into picture. So as I said, this is performed after changes are committed to the local repository. This syncs the changes from local with the remote, and not just syncs, but it is applying the changes from local to the remote. So the syntax for this is git push and then the remote repository name and then the branch name. So git push origin master. Now for example, this is I'm on master now. I'm gonna update the readme.md, or let's say I'm gonna update the test2. I've used here the Emacs. How you can also use the Vim editor or any other editor that is available to you. Now if I look at the status, then this is in modified. This is not in the staged area, so I'll do git add. Now this command will move it to the staging area. Now if I do git status, then this should be ready to commit. I can now go ahead and commit this added line. So far what happened is that this is only in the local repository, because if I go to the remote now, this is blank so far. Now what I have to do to push to the remote, I'll just push get push, not remote but origin, which is the remote repository name, and then the branch name master. It will ask for username and password. However, in module 2 I have demonstrated how you can configure keyless password, or sorry, the passwordless login with the GitHub using your SSH keys. If I go back here, then this will be available to me. So this comment is now here, hello world 2. I can go back and then look at the commit. So I have added a line. This was my commit. I am currently on the master branch. Next comes the fetch command. Now the fetch command is similar to pull command. We have not used the pull so far, but pull is used to download the contents from remote to local. Now once I have pushed the contents, then developer A, for example, I am developer A and I have pushed the contents to the repository, then the developer B will have to pull those contents or download those contents to its working directory. So what will happen? He will have to use the git pull command. So git pull command, what it does, it fetches the content to the local repository and then it merges the content. So fetch is nothing, but it is similar to git pull, but it will not merge the changes with the local repository. So fetching is what you do when you want to see what everybody else has been working on. It is similar to SPN update in that it lets you see how the central history has progressed, but it does not force you to actually merge the changes into your repository. So for example, I have 4 branches right now. I don't know why there is no master. So let's go to module 3 again. I'm on master branch. Now what I'll do is I will go to repository and edit this file, the test2 again. This is not test2. I'm editing the readme.md and I'm adding the message, editing it for get fetch, and I'm gonna save it. Now this is similar, I'm doing this from GitHub, but however someone else will be doing it from their system. For example, developer A or some other collaborator will actually be doing it. Now let's look at the contents of readme.md. So there is only this content is, this is only one heading and one line. Now what I'm gonna do is I'm gonna perform a git fetch. So this is the command. I'll do git fetch origin master. Origin is the repository name, remote repository name, master is the branch. So this will again ask for password, I guess. No. So what it did is created a temporary branch for me, wherein origin is only pointing to this, while my head is the head of my current, the local repository is pointing to, or the local working copy is pointing to the master. Now if I look at the contents of this, then the changes have not been applied. To apply the changes, I'll have to do git merge. So let's type this command git merge, and if I do the git readme, then the contents are here. Now this is we have done in two way, right? I can also look at the git diff, then it would have displayed it to me, but not now. So let's do this again. What I want to do is let's edit this file again. So what I'm going to do is I've edited this file, and now I will execute the command git pull. Instead of git fetch, let's replace fetch with pull. Right, so what happened is if I do the get readme, then my changes have been merged automatically. So it is saying that it has one file change, one insertion, and one deletion happened because we removed the line and entered a new line here. The last one is the collaborator. As I said, this collaborator is the one who is part of the core development and has commit access to the main repository. So collaborator can directly assign team to a repository, which will result in providing permissions. Once the collaborator assigns a member in the team, he will get permission to access the repository. So the role of collaborator is merging contributor branches into the upstream master or upstream relay. So collaborator is the one who is adding members to the team and merging the branches. Then he's creating the upstream or creating the development branches. For example, one example I gave, for example, I have a dev branch and some bug fixing is going on in parallel. Then I'll create, the collaborator will actually create a new branch which will called as the bug fix. It will also tag the release version within master and the release branches. So let's invite the collaborators to a personal repository. For example, we have created a personal repository on the GitHub. Now I can go ahead and I can invite. To do that, I have to go to the GitHub, and under the repository name, I have to click on the settings. Then on the left bar, there will be collaborators button, which I will go from here. So this is my repository. I can go to the repository from your repositories, and I'll go to the hello world. Within this, I can add collaborators by going to the settings, and then I can click on collaborators. It is asking for the password again. We don't have any collaborators yet, so what will happen is I have to search by username, full name, or email address. So I'm gonna add a email address, this, and I'm gonna do add collaborator. So the invite is there, they're waiting for my response. Now once I accept the repository, I will have the page. So let me take you to the GitHub. Right, I can contribute to this repository. For example, I can go to test2 and I can edit this file, right, since I have the permission. And if I go back to the Edureka GitHub username, then in this project I can see all the activities and there is no other thing. So this is the Edureka GitHub page. I can go to the, again go to the settings of this project. So I can go to the collaborators, and now you can see that I have push access to this repository. I do not see the teams because now the steps done. We have added a collaborator, but I don't see a team yet because this option is available if it is comes as an organization. So if that comes, then I can create my new team with the default repository permission, and I can decide which member will have the read access and the write access. So this can come that if the DVTS organization has, they can create a team. For example, this POC has 5 members and this team has only read access. Now this is another part of this wherein we will see that how do we configure remote repository on a local machine. What we are trying to do is that we have an existing project on our local machine and we have not added the git remote. So what we're going to do is we will adding the git remote. So if I go back to get Alias, if I do get remote, then there is none. So what I'm gonna do is I'm gonna copy the remote URL from here. I'll just close my Safari and I'll go to this project, hello world. I'll copy the remote URL and I have to execute this command, get remote add, and then the remote name and then the repository name. So what I'm gonna do is origin, and this is my repository URL. So if I now do get remote, I should see now origin. I can also see it verbose. Let's see. So remote name is the name for the remote, and the remote URL is the remote repositories URL that I just copied from the GitHub. I can see the detail link between the remote repository name and the URL, which is here. So I have my origin and this is my remote URL. For push it's also the same. This is another demo we are doing wherein we are configuring existing project as a remote repository. So what we are going to do is we are going to create a new repository on GitHub. We'll open the git bash and initialize the project. And once that is initialized, I'll add all files in the local repository by adding git add dot. Then this stage file for the first commit. So once that is there, I'll make my first commit as git commit -m, and then we will add the remote. So I'll start with this. So let's create a new repository on the GitHub. I'll go to new repository. This is public and I'll initialize with read.md and I'll take the license as general public. So I'm creating my repository. My repository is created. Now I can go back here and so I'll create new project, my project 2. I will add a new file test.txt and I'll initialize my directory. So I've initialized the directory. I can look at the get status now. So I have untracked file. I'm gonna add it. This is my first commit. So I'm committing this file from staging area to the repository. Now this is committed. Now what I have to do is I'll add a remote repository. So if I go do get remote to look at the repositories, then they should be none. So what I'm gonna do is I'm gonna copy this remote URL repository URL. I'm gonna do get remote, add the name and then the get. Now if I do remote -v, I have my get ready. Now get push origin master. So what we did is we didn't integrated the remote changes. So before this, the push, I'll have to do a pull here because we have readme.md file. So I have my, no, so what it did is there was some issue with my branch. So what I did is I just rebased my branch. And if I look here, now I'll do is I'll push it to the origin master. So now I have uploaded the project. So what we did is we created a new project, and when we uploaded this file, we added the remote URL, remote repository URL, and we have uploaded the file. So we can see the remote repository that we already knew, that we can type git remote and do -v, and it will show us the URLs that Git has stored. It will list all the remote servers which are there. So this is what we are talking about. Git remote, I can get origin, and if I add -v, I can get all the URLs. I can also rename a remote repository. For example, instead of origin, I want to, for example, if I have different remote repositories, then I can, for example, name it something else. So what I'm gonna do is I'm gonna rename the origin to repo1. If I do now git remote, so I have repo1 now. So this is just for the renaming a remote repository name. Now to remove a remote repository, we can use either of the below options. So they are both the same commands. First one is git remove, and the second one is git remove rm. These two commands. The reason for removing can be that maybe the server has moved and we are not using that particular mirror, or a contributor is not contributing anymore in the project. So there can be n number of reasons for removing the branch. In case the server has been moved, then we first remove the remote repository, and then we will add the remote repository again that we saw in the previous examples. The point here to note is that all remote tracking branches and configuration settings will also be deleted for that particular remote repository. So how can we check the remote repository? So I'm going to again do git remote -v. So I have the Git repository named origin with the Git URL is listed. So to remove it, what I can do is I can either use git remote rm and then the branch name. Now if I check this again, then this will return me a blank result. So now let's take an example. What I'm going to do is I'll quickly remove my module 3. So I'll quickly clone this. This is the same we are using. Since I have removed the remote, instead of adding the remote, cloning is much faster for me now. So I'm gonna get into this, and this is, I have the remote available. So what I'm gonna do is let's check the branches and then execute the command. So we have only one branch, which is master, which is the default branch. So now I'm going to create another branch. Let's name it as old branch. Well, now since we will cover this in more detail in the coming slides, but for now you have to understand that when I execute the code get branch old branch or the branch name, then this branch is created on the local module. Then this branch is created on my local repository, and I have to push it to the remote repository. So the command to push it is git push, then the remote repository name and the branch name. So this branch is moved. I'm gonna open another window for Chrome. And now what I'm trying to do is we're going to go to the GitHub and see if the branch has been created successfully or not. So I'll go to my repositories, module 3, and yes, there's an old branch, right? Now since we have the old branch available on git remote, so now let's remove this branch or delete this branch, and the command to delete is same. The only thing that I'll add is I'll add -- delete after the repository name. So git push origin -- delete old branch. So let's go back again to this and see if the, so now I have only one branch, which is master. Let's create another new branch, and let's, sorry, not the push, but I'll have to first create it. So I'll do git branch new branch and then git branch. This will show the new branch. Okay, the point here to note is that, as I said, the when I deleted the branch from the remote, then it was only deleted from the remote. If you can see here, there's only one branch, and this old branch is not deleted from the repository. To delete this branch completely or any branch completely, the steps will be first to delete it from the remote, second to delete it from the local. So to delete it from the local, I'm going to do branch -d and the old branch name. Now if I do git branch, I only have one branch, which is git. And now I'm going to push this new branch again to origin and then the new branch name. Yes, so now I have another branch, which is new branch. Now I can also go ahead and rename a branch. So to rename branch on the remote repository, you need to first rename a branch on the local repository. Once that rename is done, you will then push it to remote by with the same name for commands. So let's check this. For example, here what we're doing is we are checking out a new branch. We're creating a new branch, old branch, and at the same time, we're also switching that branch again. So this whole one single step can be broken down into two. Number one, we create a branch with git branch old branch, and number two, we switch to the old branch using git checkout old branch. But this single command will do the both thing. It will create a new branch and then switch it on it. So if I do git branch, then I have only new branch. So let's do git checkout. So you see it has created new branch and switched to it. But this is the local branch. This branch does not exist on the remote so far. There is only new branch. There are two branches, master and new branch. Next, what I'll do is I'll push this branch to the remote. So the command is same, git push the remote repository name and the branch name. Okay, now I have three branches, master, new branch and the old branch. And if I do this command, before I rename, so let's rename it to, here what is happening is that when we create this branch, we had only two branches, master and old branch, and then they are renaming this old branch to new branch. So let's rename this old branch to actually new branch name, new branch 1. So the command is git branch minus m, the old branch name, and then new branch 1. If I do now git branch, then I have again 3 branches, master, new branch, and the new branch 1. But if I go to the remote again, then I have not pushed this change to the remote yet. So I have only 3 branches, master, new branch, and old branch. This has not been renamed on the remote. So to rename it on the remote, what I'll do is I'll push this branch, get push, and what I'm going to do is get push colon. If we now go to this branch and let's check the branch name, so the old branch name has now been changed to new branch 1 on the remote as well. While if we go to this example, then what is happening is that we have created a new branch, new temp, and then switched to that branch. So the -m option here is for moving or renaming a branch. So generally the command follows is get branch -m, the old branch name and the new branch name. If we go and try this example, then get branch -m, let's call it temp, yes, new temp, and then we are gonna move temp to new temp. But the issue here is that they already have temp. So let's create first of all temp here. Okay, if I do now get branch, then I have temp. So the first command, what happened is, if you remember, our new branch 1 has been renamed to temp. So if I'm not providing the second argument, it will consider the default branch which is selected or the current branch which I'm on as the branch which has to be renamed. Now if I'll move temp to new temp, if I do now the get branch, then temp has been renamed to new temp. In the last step, I'm pushing this, but let's see if it will push or not. But I think it will. I'm not sure if it will work because we don't have the temp on the remote. Let's see. It has failed to push. Why? Because I don't have the new branch. I have not pushed the temp. So let's rename this to temp again, and then let's put new branch 1 to temp. So now I have the command temp now, or sorry, the branch name temp. And now if I move this temp to new temp and then push it to the remote repository, then this will work as well. In the same way, we can delete the remote branch. We already saw this example, but let's now delete this branch that we created. So the command is git push, then we pass the dash delete option and then the remote repository name and then the branch name. So -d origin new underscore temp. Will again ask for password. If you are working on remote, I strongly suggest that you should consider setting up the passwordless SSH. So this branch is now deleted. Let's verify it. Yes, now we have two branches, master and new branch. We deleted the new temp. Now this is the another option we have in when we are pushing our changes to the remote, which is the -f or the force push flag. So get push -f is a short for get push hyphen hyphen force option. If I go and we can try up. So this is the option we are talking about, force. So this option will force a push when otherwise Git would reject your Git push because you might have changed your repository history in pushing your repository. So force push also lets you overwrite someone else's commit which have been pushed after your last pull. For example, let's consider that your repository is at commit A and you change something locally and commit it. So this now becomes the commit B. You push commit B to your remote repo. So both are now B now. Now you decide to change something again and replace your commit B by commit B hyphen. Now you want to push your commit B hyphen changes to the remote repository. A plain git push will not work. So you can now remove commit b from your remote repository and push b hyphen instead with git push dash dash force. So what will happen is it will override the changes and will replace your branch directly. Be aware that force pushing is a highly dangerous and unclean solution when you are working in a shared repository. So instead of you, someone else might have pushed, for example, b hyphen, and if you're trying to commit now b hyphen hyphen, then you'll get a merge conflict. And in that case, to resolve the merge conflict, you can overwrite your changes. However, that is not recommended and that is unclean. So all commits in the shared repository should be considered immutable. This is the best practice. And to keep your repository consistent and keep your coworkers happy, you should use git revert instead. Or you should go for manually merging the conflicts, which we'll see in the next module. So let's try this git push example. Let's see how the git push will work. So what I'm gonna do is I'm gonna go to test.txt and let's update some content in it. It says edit from remote. Let's change it to remote 1. Another line from GitHub. Let's commit those changes. So what is happening now, I have a different version on the remote, which we can consider that someone else pushed it, and we have a different version on the local. So now let's update our local repository. Please note that we are not merging the changes. We are only updating our local repository. I'm assuming we were on master, yes, and git branch. So let's check out the master as well. So now I have also fetched the master repository here. Now you can see that my changes are there, and but they are not been pushed into my file yet or merged into my file yet. I still have added from remote, but not that. So if I go ahead and change my repository, for example, let's change the test.txt. Before that, first check the status. So there's nothing to commit, we are clean. So let's edit test.txt and let's add this line. This is added from local repository. I'm again saying I'm using Emacs editor here. If you are comfortable with Vim or Nano, you should go ahead and use that. Now what I did is I updated the file, but that is not in the staging area yet. So let's move it to the staging area. Now it is in stages, and now I am gonna commit it. Added line from local repo or workspace, I can say. So now we have our remote is on different commit and my local is on different commit. So what I'm going to do is now if I go ahead and if I try git push origin master, then this will be rejected. So let's, okay, it's authentication fail. Let me try it again. So this is rejected. Why? Because the tip of my current branch is behind its remote counterpart. So we have to integrate the remote changes before pushing again. So now I have two options. Either I merge them manually, which is called as the merge conflict, which we'll see in the coming slide. But for now, we can have an unclean solution, which is overwriting all the changes. So what I'm going to do is I'm going to just add a force option here before the git. So not before, not after the git, but after the git push. So you see now my changes have been pushed here, and this changes, another line from GitHub has been removed completely. So it has overwritten my file. If I go to the history, then I can see that I have this added line from the workspace, but I don't have that change wherein I added line from the local, from the GitHub. Once we have merged the force update, or once we have did the force push to the repository, let's look at the file locations in both pre and post commit. So any file can exist in three locations, which we already know what this location are, and the same file can have different content and different locations. So the first one is remote inside the repository. So this is the remote, which is, for example, is in GitHub. Second is stage in the index. So this one is ready for commit and is the staged area. Third is the workspace, which is not in the staged area, but it is in a workspace so far. So content of these file as it was last committed to the repository. This is in the repository. This is on our local, but second one is in the stage and ready to commit, while the first one is not a stage yet, and most files are in progress state. Git won't do an auto update for a stage file with additional edit. To do that, we need to explicitly add our files from the workspace to the staged area using the git add command, which we already saw in the previous examples. The next thing we have is compare remote repos. So we already saw how the conflicts can happen. So this comparing the remote repository will come in handy with the conflicts when we'll come to that, but we can also compare our file with the remote one, or between the two locations, or between the two files, or commit hash, different options. If we do not specify any option, then it will compare to the staged or the index version. To compare the stage version with the committed version, so committed version is what is in the remote area, we have to use dash dash staged. Additional different option are comparing file within two files on the disk, comparing with two commits, or comparing file without any commit. So the command is git diff, which is this. Let's look at the help for git diff. So this will show changes between commits, commit, and the working tree, etc. We have different options can be dash dash cached, or and we can compare different files. So let's do a specific the first thing. So let's compare, we are not providing any option, the workspace to the staged version. So let's do git diff test.txt. First edit our test.txt. If I look at the status now, we have up to date, right? So let's edit test.txt and let's add this line is for git diff. Now let's compare this file. So if you see, we are comparing it with the index version. We have a b and we have added this line. This line is for git diff. This will appear in the green color, but if I go ahead and remove the line and if I do git diff, then what is happening is I have a red color which is saying this line has been deleted, and I have a plus color. There is a blank line inserted, and then there is another line inserted. Now what I'm going to do is I'm going to add this to the staged area. If I look at the status now, then this is added to the staged area. Now if I do git diff, then there are no changes because I'm comparing test.txt to one that is staged. To compare it with the remote, I have to use cached. This is added from the remote. The same comparison, the same, that this line is deleted and these two lines, one blank line and one additional line has been added, but this is now compared to the remote. I can also go ahead and compare the two files. So let's create another file, atest.txt, or let's rename it to new test.txt, and let's add, this is added from remote, sorry, not remote, let's make it from local. Now I can use git diff to compare these two files. Not git diff, I can directly use the diff command, test.txt and new test.txt. So I can clearly see that I have these changes. This is my line 1, this is my file 1, which is test.txt, and this is my file 2, which is new test.txt, and the changes have been are differentiated from this line dash dash. If I copy test.txt now to new test.txt, then these are identical. But if I go ahead and just edit a single word, then you see the only this line is coming as the difference. So there is f missing, but this complete line will be treated as a different line. We can also go ahead and compare the two commits. So we check these options, we compare two files. Now we can compare two commits as well. And how do we do that? Commits can be identified with the commit id. So if I do git log, I'll have the commit id. Now I can compare them. So let's do git diff, let's copy these. So I'm gonna copy two different commit IDs, and if I do this, then it is saying me that there were two files, test.txt and test.txt, and this line has been removed. If I look at their comments, then this is 96 file, which is updated text file. Now let's compare these two. Let's compare the latest one and this one. So this line is not there in the first file, which is test.txt, which is the latest commit. This is added from local repository, is not there in the other file. We can also go ahead and compare file with any commit. So how can I do it? You can, again, let's look at the log and then compare with, let's copy this. What I did is I compared this commit ID with the workspace file. Now there are other options as well. that we can compare with any two files on the disk, which we already saw. We can compare two commits, we can compare any file with any commit. Now to compare local branch with the remote, we already saw how this can happen, that someone else might have contributed in his copy and then pushed that changes to the remote while we have not pulled the changes yet. So first what we have to do, we have to update our remote tracking branches. How do we do that? We do git fetch and the remote branch name. Now remote branch name is origin, for example, which is the default one. Next, what I can do is I can do git diff master branch and the remote branch path. What is the remote branch path? How does it different from the master? So if I do git branch, master is my master branch path, while remote branch path will become origin slash master, the remote branch name slash the remote repository name slash the branch name. Let's go back to this again. Let's open some file, let's edit it and then do a git fetch. So what I'm gonna do is I'm going to add compare remote. Let's remove this. Let's commit this file for compare. Now what I'm going to do is I'm going to fetch this changes to the repository. Git fetch origin, the repository name. So what is it? We update the remote tracking branches. So this is my remote tracking branch and this is my master branch. Next, what I'll do is I'll do a quick diff, git diff master and then origin master. What we saw is we have compared the master branch with the remote master branch, right? Origin slash master. So what we did is we first fetched the remote tracking branch and then we compared them. Now this command will list all the branches. So you can see that master, new branch, new tab, and then it is also showing the remote branches. So we can choose the branch name from there. For example, this option that we already saw, masters origin slash master, where master is the local master branch and origin slash master is a remote namely origin and master branch. So origin is the remote repository name and master is the branch name. So fork is the another command that we have in the GitHub. So what happens is that it allows us to copy other repositories for our own use. So we can experiment with the changes or we can go ahead and start the development from that branch. So this is like a very popular and the useful feature of GitHub mainly. So it acts as the bridge between original repository and the personal copy. By personal copy, we mean that we can copy the data, the complete metadata in the repository, and then we can start working on it. The only thing we won't get are the settings. So this is core of the social coding, which is called as open source at GitHub. So folks are used to suggest changes or to use someone else's project as a beginning point for your own. For example, if someone has done, this is very popular when you come to blogging. For example, if you're using some theme or some blogs, or maybe you're building some analytics project of your own and someone has already contributed to the GitHub, then you can fork that repository and then you can start contributing in it. Of course, you will have to check the license if you're building that product for or developing that code for the remote for the production use. Then you will have to check the license and then you can start contributing. So the best example of using forks is for bug fixes, where you fork the repository for fix issues and raise pull requests to merge in with the original branch. So it is a two-step process. One, on GitHub we go to the repository and click on the fork button. After fork, to work on local repository, you can either clone it or download it. For example, so what I'm gonna do is I'm gonna go to some username, for example, and I'm gonna go to, let's say, the bit start, not the bit starter. I'm gonna go to this credit card analyzer and I'm gonna fork this repository for my use. So if I fork it, so now this repository is available for my use, right? I can now use this as a starting point for my project, and to use this I have to clone it again. So if you see the git, the repository name has my username, the repository URL has my username. So I go ahead and I clone it. So I have this repository at my this local workspace for my use. So I can add anything and then commit, push it. For example, let's add this file. This line should be treated as dummy. I add this and I commit this. Added dummy line. and now I push it. So let me check the first branch, git and the remote, git push origin and then master. Then it will ask for my credentials. So if I go here and check the history, then I have this dummy line available. But if I go there for the place where it is forked from, then you can clearly see that the change does not exist there. So I have this copy of the project as my repository. Git is a largely distributed, which means there is no inherent concept of upstream and downstream. It depends on the way data flows. For example, the other repo will be upstream even when data is pushed onto it. And if I'm pulling from the other repo, then other repository is upstream and my repository is downstream. For example, the in credit card analyzer project, the repository of this user is upstream while my copy is downstream. This is relative between the two repositories. So to sync changes which are in the original repository which we have forked, we configure a remote that points to the upstream repository, and to do it we have to do what? We have to just use this command get remote add upstream and the repository name. So if I do get remote -v, let me first copy the repository URL, and if I go here and if I do, then I have to add this. I have added the upstream. If I again do the remote -v, then you can see I can see the upstream URLs for both fetch and the remote, which contains the original owner of the repository. I can also do this sync. So instead I can use the upstream repository name, and then I can check out the forks local branch. So this is the fork means the downstream repository. So this is similar to other. This will work like any other repository on my local. If I do get branch, then I can see there's only one branch, but the remote are different. We can also consider merging it. So instead of using origin, I can use upstream. We are already up to date. I can also do the get diff, or let's say not the diff, but the difference is that this line should be treated as dummy, does not exist in the upstream. It is only in my remote repository. So this is the change that I can see. Why it is only showing my branches upstream. So I cannot go ahead and make changes in the upstream because I don't have the ownership. I can suggest changes and then it will be up to the approval of it. However, if something has been changed in the upstream, then what I can do is I can merge it with my local repository, which will be similar to pull. So it will pull the data onto my local repository and I can work on it. So now coming to pull. Pull is the very useful command. We have been using it. So this is like opposite of push. In push, we are pushing from local repository to the remote, while in pull, we are downloading the data from remote to the local. So that downloaded data has been pushed by some other user for some other commit or from other feature. Might be they have added some feature or they have added some bug fix or they have changed something. So we are downloading, we are updating our repository on our local. So this is the source repository and we have feature source as the branch name. We do a pull request and then this is our destination repository and this is the master destination repository. This is the branch name, the master branch name. So how it will work is that if someone has added something in the destination repository, then I can pull it onto my local repository. So this is commonly used this is a very general command in the Git, which is commonly used by teams and organizations which have more than one contributor. So developers work on their feature branch and raise a pull request to merge to shared repository. What it means is that we can have multiple branches and then we can have a pull request created. Open source projects usually pull requests to manage changes from different contributors because open source projects have many contributors who are contributing to them. So they use pull requests to manage the changes. Now, how do we create a pull request? Now, after we have made changes to the fork, after we have forked the project, we create a pull request to ask us upstream request repository to merge our changes. We are not committing them directly. The word here to note is the ask. So below the steps, we confirm the repository we want to change. We select the branch of the upstream repository to merge and we use the base branch from the drop down menu. Once we selected the base drop down menu, we select your fork using the head fork drop down menu, which is this. And then we select the branch we want to make changes from compare branch drop down menu. So let's take this example. So let's push, we already have pushed something, right? So what I'm going to do is I'm create a pull request. Before I go here, let's read what it's saying. So pull requests help you collaborate on code with other people. As pull requests are created, they will appear here in searchable and filterable list. To get started, we should create a pull request. So let's create one. This is our base branch. Base branch is the original branch. This is our head fork. So the base branch name is master. Again, we have only one branch and the master. Now we can see the comparison. We have added one line and there is no change as such. This commits has been made by Edureka Global, which has added a dummy line. These are the comments, and this is done on December 3rd, 2018. So we have one change file with two addition. One is the blank line and second is the line we added. Now you can also see the split view, right? This is the split view. This is the base copy and this is our working copy, the Edureka GitHub. So let's create a pull request. So now we have added a dummy line and it says it is not merged, but it says it wants to merge one commit into Ayushuri master from Edureka GitHub master branch. This branch has no conflict with the base branch. Now if I go here, then we won't be seeing this because till the time someone approves it. Now this is the pull request we are seeing. Before we do that, let's see if this has been added in the readme.md, which we are seeing here. We won't be seeing here because this has not been approved, but we can go to pull request and we can see it here. So let's try to open this as a public user. So we are getting the whole history. We are saying that this is the commit and this is the file changed. So we can clearly see once someone approves it, then this change will actually appear in the original repository, which is here. So this is how they manage with open source project which have millions of developers. They fork it, they work on their own, and then they create a pull request. So we are providing title and description, and then we can also control the access which is appearing at the bottom, which allows for edits from maintainers. So someone else might change your pull request, make a small change here and there. We click on pull request and it will be available. So we looked at in this module 3, we looked at what is repository, we looked at local and remote repository names, we discussed in detail the buzzwords, not just the buzzword but the different commands. We looked at the upstream, downstream, creating pulls. We also discussed the force option, the how to override the changes in Git. We also saw how to use git diff command to see difference between the files. We will meet you in module 4, which is branching and merging. Thank you.